Welcome to qnawire.
Okay, let's go ahead and solve this problem. We're given another surface integral where we're evaluating x squared, y squared, z squared through the surface S. And they tell you that S is a paraboloid where it's above the xy plane. So it's drawn in the figure right there. Now, it's very important that you're able to actually figure out the limit of integration for this problem, even though you are allowed to use a calculator. So that part we're going to pay a little bit more attention to. So as usual, like in the previous problem, we're first going to express the function of x comma y comma z with respect to x and y's only. So because we're going to use this formula again. So we're going to work on g of x comma y. Fortunately, it's already given in this form. So the inside part, let me call that the square. Square is equal to x squared y squared times 3 minus 2x squared minus y squared quantity squared. Okay, let's call this g of x comma y. We're going to need the square value later, but for now we're going to work on g of x comma y. Okay. When we find the g's of x, we just need to take the partial derivative with respect to x, so it's quite simple. Negative 4x, but we're going to square it. So you will have 16x squared. Through similar process, we can figure out the partial derivative with respect to y. After square it, we will get 4y squared. So let me call this triangle, which is this portion. This is equal to the square root of 1 plus 16x squared plus 4y squared. So now it's just a matter of figuring out what the limit of integration is going to be. So this is the part that we want to pay special attention to. So the bottom right here, unfortunately, it's not a rectangle or a circle. It's going to end up being an ellipse. And the reason why I know that is because when I let z equals to 0, I know that 2x squared plus y squared is equal to 3. Dividing both sides by 3, I can rewrite this as x squared divided by 3 over 2 squared plus y squared divided by 3 squared. It's one of those things that we learned from Algebra 2 or pre-calculus. It shows up right here. So if you want to review how that works, try to go back to stuff regarding ellipses and how to find the center, the major axis, minor axis, etc. Okay. Anyhow, from here we know that y changes from negative square root of 3 to square root of 3. X changes from negative root 3 over root 2 to root 3 over root 2, but this is a double integral, so the path that I took was I want to find the integral. X goes from negative root 3 over 2 to positive root 3 over 2. Now the y is the issue. We have to be very careful here. We want to go from this equation to that equation with respect to x. So we have to actually solve for that value. We can do that by isolating what y is from there. Y will end up being 3 minus 2x squared, and then you take a square root. Don't forget the plus or minus. So the bottom equation, remember this is the negative x side, so it's going to be negative root 3 minus 2x squared. The top equation would be root 3 minus 2x squared. So that's going to be the limit of integration for the y. Okay, and then if we just plug in the f of x comma y comma g of xy times the square root of 1 plus g of x squared plus g of y squared. The order I took was dy dx. And if you plug in this into the calculator, it might take some time because it's quite a complex looking integral, but eventually it will give you an answer. So this, according to my calculator, it is approximately 3.48947. And the answer wants to be correct to 4 decimal places. So let's call that a 5. And that's how you do these kind of problems.